Hello students, welcome to my class on operating system. Today I will discuss the synchronization problem and the solution with the help of the hardware. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. After completion of this lecture, you will be able to understand the problem of the critical section and how we can solve the critical section problem with the help of the hardware. That means the hardware based solution. Now, in my last class, I already discussed that what is the critical section problem and how to solve the critical section problem. So as you know, in case of software based solution, so critical section problem can be solved using the different solution. One of them solution is the software based solution, which is called the Peterson's algorithm. So the basic logic behind the Peterson's algorithm is like that. If you have a critical section, so I'm writing it CS is the stands for the critical section. So if you have the critical section, so if any process wants to access the critical section, before accessing the critical section, the process has to get the lock. So we can write down that get lock. Okay. After getting the lock, after acquiring the lock, the process is able to access the critical section. Fine. Now, after completion, the task of the critical section, the process has to release the lock. Fine. So the next is release lock. So make it quite large. I'm writing it release. Okay, so that is one module. And you can repeat this same process again and again. So the important thing is that if you want to write down or generate your own algorithm to solve the critical section problem, you have to write down the code for the get lock section. You have to write down the code for the release lock section. These get lock section prevent multiple processes to access the critical section at the same time. So that means if there are two processes P1 and P2 and both wants to access the critical section, both the processes have to pass through the get lock section. And the get lock section will allow any one of them, either P1 or P2, to access the critical section. So suppose if P1 gets the access to execute the critical section, in that case P2 will not be able to access the critical section, it has to wait. So this get lock section is very much important because it control the accessing of the critical section, and after accessing the critical section, the process has to pass through the release lock section, which will modify the condition so that the new process get the chance to access the critical section. So that is the basic idea to write down any algorithm to solve the problem of the critical section. Now, in the last class, I discussed the Peterson solution. In the Peterson solution, you can see that we can solve the critical section problem if only two processes can access the critical section. But if the number of processes are more than two, in that case, the Peterson solution cannot handle the situation. So now we will discuss another solution, which is called the hardware-based solution. Now, the important thing is that why we go for the hardware-based solution. The hardware-based solution, basically, it is very easy to implement and it improves your system efficiency. Fine. So in most of the system, some hardware instructions are already there and we can access the hardware instruction effectively to solve the critical section problem. Fine. Now, the important thing is that this hardware, if we solve the critical section problem with the help of the hardware, so in that case, we can stop the occurring of the interrupt. Fine. And this interrupt is very much dangerous, because if we go for the software based solution, then in between the software based solution, the interrupt can occur, and the interrupt can hamper the execution of the algorithm. But if we go for the hardware based solution, the hardware based solution lock the interrupt procedure, so that the critical section, while the one process is executing the critical section, no other process, no interrupt can hamper it. So that's why we go for the software based solution. So now I will show you how the hardware based solution will help you to solve the critical section problem. Fine. Now the hardware based solutions are of two different types. One is test and set, another is swap algorithm. So first I will discuss the test and set method. In the test and set method, there is a common variable which is called lock. Okay, so the common variable lock is present over here. So we write down it lock. It is a common variable, memory location. Now here there is a function which is called the test and set function, whose return type is boolean. So I am writing the functions for the test and set. So boolean, test and set, and here we are also passing, I'm discussing it later. First write down, I will write down the functions for test and set, and how it is working I am discussing. Boolean, let us take another variable rv, which is equals to target, and star target is equals to true, and return rv. So how these test and set functions help us to solve the critical section problem? So let us say there are two processes. One is the process P1 and another process is P2. Okay. Now consider the body of the process P1 is like this one, do, then there are some beginning section. Now as I discussed that to access the critical section there is an entry section. So I will write down the code for entry section. So the code for entry section is while test and set ampersand lock. Okay, so we are passing the value of the lock, and then we are putting the semicolon. Fine. Now if the process P1 can come out from the while loop, then it can access the critical section. So this is our beginning section, and then it's set the lock is equals to false. Okay, and then this is a remainder section. This is a general structure of the process, and this is a while one. So same block will be present for the same thing, same block is present for the P2 also. So I'm just copying it. Oh, there is no space over here. So I think where I should write it somewhere else. Here you can see two processes are there, P1 and P2. So in the process P1, there is some beginning section, some set of instruction will be there, and this is a remainder section where some set of instruction will be there. But between the beginning section and remainder section, these sections is very much important, because here our critical section, this critical section lies. Okay. Now, to access the critical section, the process P1 has to pass through this section. This is called our entry section. And after execution of the critical section, the process P1 also has to pass through this section. This is called the exit section. Okay. Now, what happened in case of test and set algorithm? As you know, there is a common, as I already told you, that there is a common memory space. Okay. So let us say this memory space, name of the memory space is lock. Lock is a variable. And this lock space is initially set as false. Okay. Now, if P1 wants to access the critical section and at the same time P2 also wants to access the critical section, what will happen? So let us observe it. Suppose P1 wants to access the critical section. So it comes over here in the beginning section. It executes its parts, and before accessing the critical section, P1 has to pass through this entry section. So pass through the entry section means it has to call the test and set function, and by sending the parameter lock, and what is the value of the lock? False. Okay. Now, while P1 will execute this test and set function, so this value of this lock and target will point is the same location. This is also target. So what is the value of target? It is also false. So now the value of RV. So RV is another memory location. Now what will be the value of RV? The value of our RV will be is equals to target. That means false. So it will be set as false. Now target is equals to true. So that means this false will be overwritten by true. And return RV. What it will return? It will return false. So this function, after calling this function will return false. Okay. So while this function will return false, so while false, that means it will come out, the execution will come out from the while loop, because you can observe one important thing, after a while there is a semicolon. So while false means the condition inside the while will not be satisfied, so we will come out, the execution will, control will come out from the while loop. That means the P1 can execute the critical section. Okay. Now while the P1 is executing the critical section, at the same time, at the same moment, if P2 wants to access the critical section, P2 will execute the same entry section. So it will call the test and set function and send the value of the lock. Now what is the value of the lock now? True. So it will send true. Same test and set function will be executed. So Boolean true, RV is equals to true. Okay, RV is equals to true. So that means this false will be overwritten by true. Now the target is equals to true. So target is already set to true. So true will be overwritten by true. Fine. Return RV. So what it will return? It will return true. So the test and set function will return true. So while true, condition of the while loop will be satisfied. So the execution continue inside the while loop. That means after while there is a semicolon. That means infinite while loop. We have used the concept here. The concept of infinite while loop has been used. So the control will stay inside the while loop. It cannot come out from the while loop. Fine. Now, so P2 is not able to come out from the entry section. It is repeatedly calling the test and set function. The answer of the test and set function is true. So it repeatedly just, there is an infinite while loop. Okay. So now what happened? P1 is now in the critical section. P1 is at this position. So while P1 will complete the execution of the critical section, it will execute the exit section. So it will set the value of lock is equals to false. So this true will be set to false while the P1 will execute the exit section. So as soon as P1 will set the value of lock is false, so P2 is continuously monitoring, calling the test and set function and monitoring what is the output. So as soon as P1 will set the value of the lock false, in the next iteration, while the P2 will call the test and set function, it will send the value of lock. So that means the now the target is false. RV is equals to target. That means the true will be overwritten by false. Now target is equals to true. So this false will be overwritten by true. Fine. And return RV. So what it will return? It will return false. So that means for the P2 function, P2 process, now after this iteration, the last iteration, the condition of the while loop inside the while loop is false. That means the execution, the control will come out from the while loop. So as the control will come out from the while loop, that means the P2 can execute the critical section now. What is the position of the P1? P1 has completed the execution of the exit section. Now P1 is in the remainder section. Okay. So P2 will execute the critical section. Then while the P2 is executing the critical section, if some other process P3 wants to execute, so consider there is some other process P3 that also wants to execute the critical section, the P3 will also execute this while loop, that means this entry section. But as P2 is executing the critical section, the value of the lock is true. So P3 cannot execute the critical section. It will continuously executing the test and set function, and it is in the while loop. Fine, infinite while loop. It is just moving. It is continuously executing the test and set function, and it is present. It cannot come out from the entry section. Fine. So in this way, multiple processes, if multiple processes wants to execute the critical section, then this test and set function, this entry section and this exit section controlled in such a way that one process at a time can execute the critical section. So here you can see that while P1 is executing the critical section, P2 cannot execute the critical section. P2 has to wait. Then after completion of the P2, if P3 wants to execute the critical section, then P3 will get the chance. Okay. So in this way, by using the test and set function, we can control the execution of critical section one by one. Now, next I will discuss that as I told in my previous class that while you will design the critical section algorithm, you have to remember that three conditions must satisfied. That means the algorithm which is designed to solve the critical section problem, that algorithm must satisfy three conditions. So what are those three conditions? The conditions are, first one is a mutual exclusion. I'm writing the conditions. The first one is a mutual exclusion. The second one is bounded waiting time. And the third one is progress. Okay. Now, mutual exclusion and bounded waiting time. So you can see the mutual exclusion is satisfied in case of test and set algorithm. How it is satisfied? Mutual exclusion says that the critical section must be executed by one process at a time. So here you can see the test and set algorithm is designed in such a way that while the P1 is executing the critical section, P2 cannot execute the critical section. Fine. So the mutual exclusion condition is satisfied over here. Now next is bounded waiting time. So here you can see that, so what we will do, we will tick it. That means the mutual exclusion condition is satisfied. Next we will observe whether the bounded waiting time is satisfied or not. You can see that while the P1 is executing the critical section, P2 has to wait. But how long the P2 has to wait? P2 has to wait up to this period. So let us say T1 is the execution time of this period. So to execute the critical section, to execute the exit section, the total time required is T1. Fine. Again, I am repeating, to execute the critical section, to execute the exit section, the total time required is T1. So if T1 is the total time required, T is a finite amount. So P2 has to wait for how long time? P2 is in this section. Okay. P2 is in this section. P2 can come out from while loop after P1 will execute that exit section. So to complete the execution of the critical section and to complete the execution of the exit section, P1 is T1 amount of time. That means P2 has to wait for T1 amount of time, and T1 is a finite amount. So that means the waiting time is also bounded. And the last one is the progress. Progress means while P1 is executing the entry section, after execution of the entry section, after come out from the entry section, P1 has to execute the critical section. After execution of the critical section, P1 has to execute the exit section. After execution of the exit section, P1 has to execute the remainder section. After execution of the remainder section, again P1 will go back in the beginning section. It has to execute the beginning section, and then if P1 wants to execute the critical section once more, it has to again check the entry section. It has to pass through the entry section. Okay. So you can see that there is a progress. That means there is no haphazard execution. Arbitrary execution is not there, present over here. So there is this line of execution is there. So that means progress is also there. So once the P1 will execute the critical section, it cannot again go back to the entry section, or it will not stuck. It will not stop in that section. So there is some progress. Fine. So the progress, that means the third condition to design the mutual exclusion, design the synchronization algorithm is also satisfied. That means what we can conclude? We can conclude that test and set instruction is a test and set algorithm is a valid algorithm to solve the critical section problem. Fine. Now, next we will discuss another hardware based algorithm which is called the swap algorithm. So, in swap function based method, as you can see, I have written the function for the swap. So here you can see there are two variables. One is A and B, and we are just swapping. This is a very simple code, the same code for the swap function. So we are swapping the value of two variables. Fine. Now we will discuss the algorithm. Here you can observe there are two variables. One is a key variable and second one is a lock variable. Okay. So the key variable is either set to true or false. Fine. But there is one lock. Now, so each process has its own key variable. So P1 also has its key variable. P2 also has its own key variable. But there is a single lock. Fine. So there is only a single lock variable. Clear? So mainly we are dealing with two variables. One is key variable, second one is a lock variable. In case of key variable, each process has its own key variable, but lock variable is common, which is shared by both P1 and P2. Initially, the lock is false. That means, so you can compare with an example like at a room. Fine. A room which has a lock, the door is locked. Now, if a person wants to enter into the room, the person has to gather the, initially the room is open, but if a person wants to go inside the room, the person has to go inside the room, it has a key and it has to lock the room. So once the room is locked, then no other person can enter into the room. The same concept is used over here. So initially the room is open, that means nobody is accessing the room. So initially the value is false. Okay. Now if process P1 wants to access the room, access the critical section, so here room is the critical section. So here if the process P1 wants to access the critical section, what will happen? It has to pass through the entry section. So this is our entry section. And this is our exit section. Okay. So P1 has to pass through the entry section, then P1 can access the critical section. The same is true for the P2 also. So if P1, after execution of the beginning section, if the P1 wants to access the critical section, it set its own key is equals to true. So it will set its key is equals to true. Okay. Now while key is equals to true, so value of key is true, so while condition will be satisfied. So in that case the swap function will be called. Okay. Now the swap function will be called. Here we are sending the lock and key. So what is the value of lock? Lock is false. So that means the A is lock and this B is the key. So lock, that means the value of A is false and value of B is true. Fine. Now it is taking a temporary variable and swapping the value of A and B. So after performing the swapping operation, this value of lock will be true and the value of key will be false. Okay. So now after calling the swap function, the value of lock and key will be swapped. Then again it will execute the while loop, as it is while loop. So now it will check whether the key is equals to true or not. Now what is the value of key? False. False is equals to true will not satisfied. So P1 will come out from the while loop and it will execute the critical section. Now if while P1 is in the critical section, that means P1 is in this region, if P2 wants to access the critical section, it has to pass through the entry section. Now if P2 execute this entry section, it will set its own key is equals to true. So it will set its key equals to true. Now true equals to true will satisfy. So it will swap the value of lock and key. Fine. So here the B is the point to the key location. So while the P2 will call the function swap function, so it will send the value of lock. What is the value of lock? True. So it will send true. Fine. And key is also true. So it will send true true. And if the true true will be swapped, then true will remain true, and that means the lock and key, both the variable will remain true. Fine. Now, so true is true will be swapped, and again process P2, again for the process P2 while condition will be executed. What is the value of key? Key is true, true equals to true. So this section, that means P2 cannot come out from this entry section. It will continuously executing the while loop. It will check the condition, call the function, again check the condition, call the function, and this process is going on. Fine. Now P1 is in critical section. Now once P1 will complete the execution of the critical section, P1 will execute the exit section. Fine. And while the P1 will execute the exit section, it will set the value of lock is equals to false. So while it will set the value of lock equals to false, so this lock will change, the value of the lock will change and it will now become false. Now you can remember that this P1, P2 is continuously monitoring, continuously checking the condition of while loop and continuously calling the swap function. So once the process P1 change the value of lock equals to false, so in that iteration, while the P2 will call this swap function, it will send the value of lock is equals to false and key equals to true. So it will send the value of lock equals to false and key equals to true. False true will be swiped, and again the lock will be true for by the process P2 and the key will be false. Fine. So in the next iteration, while the process P2 will execute the while condition, what is the value of the key? The value of the key is false. False equals to true will not satisfy. So P2 will come out from the while loop. Come out from the while loop means it can come out from the entry section and P2 can execute the critical section. So in this way, you can see if two processes P1 and P2 wants to execute the critical section, then both the processes cannot execute the critical section at the same time, that means simultaneously. So while P1 is executing the critical section, P2 has to wait, and while P2 is executing the critical section, P1 has to wait. Fine. So in this way, P2, after completion of the execution of the critical section, P2 will execute the exit section and it will set the value of lock equals to false. So lock will be false. And once the value of lock is false, then some other process P3, if wants to execute the critical section, P3 can execute the critical section and P2 will execute the remainder section. So in this way, the process P1 and P2 will continue its execution and both the process cannot execute the critical section at the same time. Fine. And again, we will check whether this swap function based method can satisfy all three conditions of the critical section algorithm or not. So what are the three conditions? The first condition is mutual exclusion. So here you can see that mutual exclusion is also satisfied because once the process P1 is executing the critical section, P2 cannot, and while the P2 will execute the critical section, P1 cannot, or some other process P3 cannot. So in this way, multiple processes can execute the critical section one by one. So mutual exclusion is satisfied. Next is bounded waiting time. So in this program, in this algorithm, you can see that waiting time to execute the critical section and the remainder section, exit section. So assume the total time required to execute this section is capital T. So if while P1 is executing the critical section, P2 has to wait inside the while loop. How long it will wait? It has to wait for T amount of time, and which is a finite time. So what we can say that it is also satisfying the condition of bounded waiting time. And if you observe that in this algorithm, the progress is also there because each process has to execute the entry section, then critical section, then exit section, remainder section, and again to execute the critical section, again it has to go back to the entry section to check for the entry condition, and then it can execute the critical section. That means there is a flow of the process. That means progress is also there. So that means the swap function method to solve the critical section problem also can satisfy all three conditions. So in this way, the hardware-based solution, so here everything will be implemented in the hardware level. All the instruction can be implemented hardware level to stop the occurrence of the interrupt, and the processes can solve the critical section problem. Fine. So that is all about the hardware-based solution of the synchronization problem. Now, in the next class, I will discuss another problem which is another solution which is called the semaphore, which is very much important. So I will discuss that what is the semaphore, what is the binary semaphore method to solve the critical section problem, and what is the semaphore based method to solve the critical section problem for multiple processes. Fine. So that's all for today's lecture.